All right. Good afternoon, everybody. Thank you so much for joining our webcast today on governing the data lake. So my name is Kelly Shoup. I'm the Vice President of Marketing here at Zaloni, and I'm pleased to be here today with a special guest, Tony Baer. Tony is the Principal Analyst of Information Management at Ovum Research. So what we were planning to do today was have more of a discussion format for our webinar rather than just presenting a set of slides. So Scott Gidley, who's Zaloni's Vice President of Product, has joined us today, and he's going to talk with Tony about data lake governance. We're expecting to go for about 30 minutes, and we'd also like you to feel free to participate. So if you have any questions that you'd like us to address within the flow of the conversation, feel free to go ahead and post your questions in the Q&A chat box as we go. There's no need to wait until the end. We will do our best to get to them within the 30 minutes, and then we will do a little Q&A after if there's still some remaining questions. So if you're having any issues viewing the charts that I have right now, you should see one up here that says meet today's speakers. If you're having any trouble viewing that, go ahead and post that, and Annie Bishop on her team will try to help you through that. So before we get there, though, I need to do my 30-second advertisement, so bear with me. What I want to do is give you a really quick introduction to who we are and why we care about this topic and why we're bringing this to the table. So Zaloni provides a data lake management platform for enterprises that are trying to transition to these next-generation data architectures. And we work with enterprises to build production data lake implementations that are organized, they're governed, they're actionable. And our flagship product that helps us do this is called Bedrock, and it's a fully integrated data lake management platform for big data. You can also see on this chart Mica. We offer Mica as well, and that's a tool for self-service data discovery, curation, and governance of the data lake. What Mica, alongside Bedrock, helps organizations do is provide more access or more controlled access to the data for their business end users. So now what I'd like to do is move on to the topic at hand and the reason y'all are here. So Tony, I'm going to start by, I'm going to hand this over to you, and perhaps you could give us a quick introduction to your research report.
Okay. Thank you, Kelly, and I'd like to thank all of you for taking time out of your day to join us in this discussion. It's an area that we've been getting actually here at Ovum. It's been a sharp, uptick in inquiries that we've gotten just this year alone on data lake, which shows me essentially that basically this is starting to enter the agenda. We'll go into that a little bit more, but anyway, my background is I lead the big data and data management research area, at Ovum. And about 5 years ago, I just saw something very interesting happening, which was that basically it was a major sort of tectonic shift in architectures, where basically we were dealing with scale in a very different way. In the early internet era, we dealt with scale really by trying to abstract all the logic, in middle tier or end tier, and we basically used the application to essentially cache data to make up for basically all the I/O problems with databases. The problem was that in the meantime, as basically pioneers like Google, all those big internet companies finding that to basically to produce better better ad placement or improve search indexes or what have you, that they really need to go through basically what would be considered at the time obscene amounts of data, and had to develop new strategies for dealing with that. And what we found over the past 5 years is that this is not only a problem for the Googles of the world, it's a problem for basically for enterprises that are trying to do things like, for instance, improve on how they act on, let's say, customer 360, or basically deal with security issues or risk mitigation and so on, or even just taking advantage of some of the new commodity scale out technology to lower the cost of computing of some very common tasks. So in our report, what we really found this year is that data lake was really starting to enter the agenda. We go into that a few slides down from here, but on this page, these are basically the conclusions. We're going to starting with the conclusions, and then we'll go into kind of the build-up. But our conclusions from all this, well, the first one should not be surprising which is that data lakes, should be managed. I mean, there have been lots of, there's been a lot of discussion about this. The issue is not new, and there have been a lot of terms used for what happens if you don't manage the data lake. You end up, just dumping data in without any concern for what's going in there or the quality of it, or basically any types of concerns about, who gets access. And the fact was is that in the early days of, of big data adoption and adoption of platforms like Hadoop, it wasn't such a big concern when we were just doing things, ingesting entities such as log files. But as basically the use cases for, for Hadoop and for big data have very much, evolved, we're now seeing basically, much greater variety of data, including data that comes from sources that we would consider to be sensitive. And so our conclusion was that, for a number of reasons, which we'll go into, further in, is that, if you have a data lake, you better manage it. You better know what's in there. You better have control of the data that's going in there. You better have control over the process for turning that data into information. That's just that's a real 100,000-foot level, and we'll be discussing that, with Scott, along with Scott in a lot more detail as to what that really means. The next point, which is that data lakes must have the capability to ingest all data and related metadata. This is basically sort of a technical definition of what a data lake should do. And basically, in very simple terms, it basically can ingest data that would be a superset of what you traditionally would have put into a data warehouse or a data mart. And so the data lake is basically, it ideally should be able to act as a common repository for all forms of data that your organization may consider relevant, for its use. The next point, which is that data lakes will only succeed if they become shared resources. And that basically is a reflection of the idea that a data lake, if you're going to now really expand the use case of your big data platform to become a data lake, it really becomes an enterprise system. And so therefore, the investment of time and resource in there will only be worthwhile if you can expand your use of this platform beyond, let's say, your classic power users, or if you're lucky enough to have some data scientists or R or Python programmers on your staff. No, this needs to be accessible. I won't say to everyone, but it needs to be accessible to a broad cross-section of business end users, as well as the more traditional audience of data scientists. The next point, which is that, and this was a very interesting one, and we'll be discussing, Scott and I will be discussing this in much further detail, is that there's a basic change in governance when it comes to data lakes compared to, say, data warehouses. Data warehouses, it was basically IT, IT and the technology folks were really in charge of basically essentially of making the data suitable, for consumption in a data warehouse. This is all IT's function. The fact is that is just not going to work in a data lake. Because the task is too vast and too changing. And so this really needs to become a much more, just as data lakes must become a shared resource, the governance has to become shared as well. So business users must be prepared to take responsibility for curating data. And that may be, there may be some challenges getting there, which we'll talk about some more. And then finally, the last couple points is that, obviously, and this should not be surprising, as data lakes are relatively new, the maturity and readiness of basically the tools, the technologies, and the best practices are still forming. So, and from that, the last point follows, which that the management of governance of data lakes should be considered to be a phased process. Rome was not built in a day. But anyway, having gone through all that, Scott, I'd like to just go back to you, and so you can get a chance to put some of your 2 cents in here. What's your take on all this?
Sure, Tony, thanks. Well, I think in general we're in violent agreement on most of the key findings here. When we speak with our customers, we see that they have a lot of challenges around the overall governance and management of their data lake and their data lake strategies. And a couple points I picked up on from the findings was regarding the ingest of all data and the related metadata. And I think that the thing we see there, you mentioned it correctly, it's a superset of the data that you would have had in a traditional data warehouse. So there might have already been governance policies, and it's pretty easy to capture data in traditional data warehouses, which is more relational in nature. That's something that's been tried and true over the last 15 or 20 years. But there's a lot of non-relational information in the data lake that you're trying to then correlate or coalesce with that information, and it may have no easy way to access or gain the metadata that you need so that you can govern all of the data and you don't get these dark spots within your data lake where there's some data you have metadata about and there's other data that you have no idea, or there's other data you have no idea what the metadata is or if it even exists. And so our approach is to capture metadata on all data upon ingest, and that could be business metadata, technical metadata about what type of file maybe it is, as well as operational metadata, how often it gets updated, who has access to it, and so forth. So by building these rich metadata catalogs, that's really the first step in governing the overall data lake. The other thing I think that really rings true is the readiness of the tools and the technologies and best practices. I think that in the open source market, if you're building your data lake on top of Hadoop, the tooling is loosely coupled at best, and a lot of it's immature, and as it matures, we need to think about how that fits into the overall governance process. And I think the phased approach of that makes a lot of sense, and we'll talk about this later on one of my slides when we look at an overall architecture for a data lake. But we see a lot of our customers breaking it up by zones and applying governance policies on the various zones. So it may be initially there's a raw zone where all the data goes and maybe only a select few folks within the IT group have access to it. But then as it gets moved from, say, the raw zone into a refined zone, there's additional policies that are placed on top of the data, and that allows you to kind of manage it in a more phased approach.
Okay. Kelly, can we go to the next slide? Yeah. And actually, there's one point which I meant to add there, and I think, Scott, you raised a very interesting point about basically that the knowledge about the data that goes in there is all over the map. And I think maybe we can sort of use that I guess, those terms that were used with earlier on of like known knowns and known unknowns and unknown and so on and so forth. That is basically going to be a challenge when basically with the data lake when you do widen out the basically widen out the scope of data that you ingest. But anyway, we have a couple slides here which really talk about stages of where data lake fits into the overall I don't want to call it a maturity model, but kind of like maturity cycle in Hadoop adoption. And what we see is that basically it should not be the first thing, because and that comes back to the very sort of definition of a data lake, which is that it really is at that point it's where this data repository becomes an enterprise resource. You don't start with basically an enterprise system on day one. You build it up by pieces, and you build it up basically based on your knowledge and based on your experience with each of these use cases. And typically, what's happened with Hadoop adoption, what's happened with big data adoption, is that it really starts, and it's not that different from a lot of other enterprise systems, which is it starts very often as a group effort and then sort of gradually spreads to where, let's say, some other departments, some other line of business units start to take advantage, and then from there it matures or evolves to enterprise. And typically, just some of the types of workloads that we've seen at those stages is it starts with, may start with something as basic as log analytics or sentiment analysis. I mean, those are some of the earliest uses that we saw from the internet firms. But actually what's really interesting on the enterprise side, it took, adoption in many cases often took a very different path. It started with basically the offloading of some cycles, whether it be compute cycles or storage, from the data warehouse, one of the, in fact, one of the earliest ones I've seen, and it's a very common pattern, is where you're doing ETL offload. Because the idea is why basically expand, let's say, your Oracle or HANA or Teradata footprint by performing ETL. And so a lot of those, there has, a lot of organizations doing that data warehouse offload for things like ETL or for certain types of very long-running batch queries has been a fairly common, pattern that we've seen of adoption. And it makes a lot of sense if you think about it, because it's a good way, it's a relatively low-risk way of basically getting your feet wet, getting experience with this new platform, and using it for use cases where there is a tangible ROI. But then as organizations start to get success from some of those early implementations, such as we basically reduced the growth of our Teradata footprint by say 50% over the past year because we offloaded some cycles and storage from it. Then other departments will then start to get interested, and that's where you start to see workloads like exploratory analytics, which initially will probably be more led by, say, your more highly skilled or your more sophisticated users, and those would be folks, say, would be running, let's say, your R, your Python programs, and basically, and it's basically a process of like searching for what's the right question to ask, searching for the signals and where the signals leading you, and there, when it gets to multi-department, you'll then start to see some line of business analytic applications, and that's where you start to see some of the business end users start to be folded in, and then operational analytics, especially as we start incorporating some of the high performance processing engines such as Spark, where now basically analytics can start to be can be employed in kind of a closed loop fashion with processing of transactions. And then basically the ultimate stage of adoption, the end game here becomes a data lake, where basically you say, okay, we've now gotten successful take up from, let's say, a handful of line organizations. Let's see if we can broaden this to be an enterprise resource. Kelly, can we go to the next slide?
So, Tony, I did want to make one quick comment
Sure.
here before we move on. I think that this slide really explains how the adoption is expanded within an organization, and I thought I'd throw in a couple actual customer case studies.
Sure.
And some examples. And so one would be one of our bigger customers started with the ETL offload or data warehousing modernization, right? They were really focused on not so much reducing their Teradata or Oracle footprint, whatever the warehouse might be, but they were trying to create new and interesting analytic data sets of data that maybe wasn't easily created or managed in that more relational world. So they could use the data lake to mash up data from various unstructured formats and create new analytic data sets that they could then put into the warehouse and use for that purpose. From the offload perspective, they had found that they were using too much of their Teradata instance for ELT types of processing, upwards of 90%. Wow. And so by doing more of the ETL offload in the data lake at a much cheaper cost, they could use their warehouse instance for what its main purpose was. So, I think there's some real value there. And then they expanded, as that was a successful project, they expanded into turning what they ended up calling their data lake, the concept of a metadata catalog that anyone could search within the organization to see what new data sets might be available that they would want, and they could make a request to IT to have those provisioned into some other type of data source that they could consume for their own applications. But I think the number one thing that prevents this maturity curve from happening is the governance, right? From the majority of our customers that we start with, it's almost their data lake or their Hadoop instance is always in that sandbox discovery environment that has very few people who have access to it, and they're worried about the governance processes to open it up to a much larger enterprise use. So I think that that's something that I know we'll talk about later, but as you see that experience to where you're getting to data lake as a 360-degree view of all of your enterprise data, the governance is a gating factor for that.
Yeah, no doubt about that. And the thing is that maybe a good sort of example of this is that we look at basically the evolution of the internet and the evolution of email. And nobody, when email was first invented, is when the internet was just used by basically by the research community. Everybody knew each other. And so nobody ever thought to put in those original email standards, basically prevention of basically people spoofing their own IP addresses or email addresses. It was never, because it was in a small group. You didn't need that governance. But then when the internet became a mass consumer platform, all of a sudden, oops, we forgot that. And so governance is just going to be essential when you broaden use, because basically the rules of engagement, which will probably be like which would be intrinsic, which will be considered be basically implicit for early users, will need to be made explicit when you basically draw that draw that user population out. So yeah, Scott, I couldn't agree with more with that. Kelly, can we go to the next slide? Oh, go ahead.
Tony, as you see organizations that you're speaking with, where are they on the level of maturity from a pure data lake perspective? Are they still in the trying to figure out how to move from that sandbox environment on, or are you seeing them start to cross the chasm to more mature, or is it all over the map? I'm just curious.
I would say basically with very few exceptions, we're really at still that figuring out how to scale from the sandbox. I mean, yes, you have maybe a handful of early adopters that have gotten to the point where, like, they said, like, oh, we've figured this out. I would say I could probably count those on probably the fingers of one hand and still have a few left over. So no, I mean, basically, we're still at the point of most organizations are still at the point of figuring out what role is the data lake going to play, and how is it, and what is its role alongside the the data warehouse, which, by the way, is not going away. Data lake does not replace it. And so I think we're still at very early stages on this, and in fact, that folks like you, folks like you over at Zaloni have like a really have potentially a very important role to play here to make this to make this sort of navigation of governance a lot less mysterious, a lot less of a black box.
Great, thank you.
Can we go to the next slide? Okay. Anyway, so this is basically, and you're going to be seeing, you folks are going to be seeing a couple of different takes on reference architectures in the next few slides. This is our take on essentially reference architecture from a governance standpoint, and we've kind of color-coded this, which is that the areas that are in pink and are basically that are basically at a right angle are basically capabilities that you would have on any data platform, because there's some things that you're going to have regardless of whether you're using this, your repository or your Hadoop platform as a data lake or not, and that would include, for instance, perimeter security. Even if it's not used as a data lake, you want to make sure that there's protection on the outside against bad people coming in and doing bad things, or the wrong people coming in. Then, of course, it's obviously like with any large data platform, you're going to have need monitor and trouble. So you're going to have basically your systems console there, so you can make sure the thing is operating properly. And of course, as part of all that, there is the housekeeping of availability and reliability, which could include like fault tolerance, high availability backup, disaster recovery. Those are not, and the thing is, those maybe were not necessarily considerations early on with Hadoop, when there was like single use cases. But even before you get to data lake, is like now that we're starting to run some more mission critical processes there, problems there, business critical problems, that becomes a factor, and you can't ignore that. And that, as I said, that is, you need to have those features in place, those capabilities, those disciplines in place, perimeter security, monitoring, availability, reliability. You need to have that in place before you even think about putting up a data lake. Then basically, cutting to the chase here. So what is the data lake? Well, you have the data platform itself. That's obviously at the lower level. Above that, and this is an area where basically we're still at very early days, is the whole idea of cost optimization. Because frankly, when you start turning this into a shared resource, you're going to have to start prioritizing things. Not everybody's going to be able to get basically priority one access, because it's going to be a lot of contention, especially given the variety of workloads between real-time, let's say streaming workloads and batch, and they're going to be both coexisting side by side, because modeling itself is not going to be a real-time workload. Never has and never will be. But on the other hand, figuring how to apply those models, and a good example of that is like real-time credit scoring, where you go in on a site and you fill in fill in some basic demographic information about yourself and some basic financial information. All of a sudden, you get your credit. Okay, this is how much credit we're going to give you. It's not that they figured that out on the spot. They're basically trying to match your profile against a bunch of pre-computed profiles, which are done offline. You'll have that, and you'll have the same thing in a data lake. Also, integration is very important, and we include that in the same layer as optimization, not because they have anything to do with each other, but it's more they just wanted to didn't want to make this diagram overly complex. But it's another system-level function or capability, because the fact is a data lake is not going to exist in its own island. It's going to exist alongside other platforms where it's accepting data from them. For instance, you might be getting an offload from the data warehouse, or if the data, you might be basically refining data in the data lake, and you decide to productionalize it. You may feed some of that refined data, to the data warehouse. So you're going to have integration with all the other data platforms that are going to exist, in your environment. Then atop that is data level security, and that complements the perimeter security that you already should have. But data level is where perimeter is looking at keeping, unauthorized users out. Data level security is figuring out, okay, how do we, what type of access do we provide to this data? What type of protection do we provide to this data? Whether it be, do we display this data as is, or do we need to mask or encrypt it or hash it in some way, shape or form, and for which classes of users? And so that is definitely, data level security is also a very important function. Then at the top is where we start getting towards what we call the self-service tier. And the part that we're going to be focusing on is that next to top level, which we call inventory, data inventory. And that basically includes a couple of processes, which we'll go into in more detail, later on. But one is the physical inventory, where we're basically trying to figure out, okay, what data is in there, and what types of basically of measures do we apply with regard to data retention, with regard to security, access, and so on. Data curation is where basically end users are essentially curating their own information. These are the data sets that we need. Those are the areas that we're going to be focusing on very heavily in this talk. Then above that is basically the application layers. The query is where you're doing the querying, the analytics tools, the analytics programs. And as I said, we've kind of grouped that towards the top, towards what we call the self-service tier, because basically, unlike a data warehouse where you basically have basically a walled garden of data and just a handful of things, or a finite range of queries that you can run against it, in a data lake, basically all the boundaries are off. So self-service is going to be really essential for a number of reasons. Scott, what's your take on this?
Yeah, so I think that we see the same types of things, and as we transition to the next slide, we will kind of go through how we fit into that architecture, or how we see organizations fitting in with that architecture. And when we look at the data lake, or when I see our customers looking to start out their data lake journey, the first part of it would be on what you call the data platform. How are they building and managing the rate of change within the Hadoop ecosystem and the skills gap that creates? So I think this has gotten much better over the last couple of years. The Hadoop distributions have matured. They're including more tooling for monitoring and upkeep of the Hadoop clusters themselves. But there still is the skills gap. Traditionally the data warehousing BI tooling was very SQL-driven and application-driven, and now you're having folks have to learn things like MapReduce and Spark and Scoop and Uzi, and you go through the whole alphabet soup of the different pieces of the open source landscape. And that skills gap creates these unicorn of individuals who are hard to find and even harder to keep in organizations. So they're looking for tooling to smooth out some of this process. We also see, and I'd be interested to get your feedback here, Tony, the complexity of environments that are the mix between cloud and on-premise. That hybrid environment for their data lake has also caused some struggles with our customers. But that's sort of managing that building platform, which would be sort of the bottom couple of layers of your architecture.
Right. Well, number one, that's Scott. That's basically an issue. It's not confined to data lake.
Right.
Basically, I mean, the whole rationalization of basically the workloads and where you deploy data between cloud and on-premise, and making that seamless is a very general issue. Which, of course, data lake will have that as well. Kind of like going back to the previous diagram, that would be something. That would be an issue that would be, I guess I would call it in that pink area, which is this is a very general issue, and you're only just starting to see features that are coming in. I mean, from the database folks, for instance, Microsoft SQL Server 16. You basically have a stretch capability. Oracle has its capability for going to the from Oracle on-premise to the Oracle public cloud and so on. Those are features that you're starting to see implemented within vendor stacks, but generically, basically trying to make this transition, which will being in basically a more heterogeneous environment is still going to be quite a challenge. And basically, so we still have that's going to be a challenge that's going to be with us for a while. Data lake.
Right. And I would just echo that. I mean, from a data lake specific perspective, in the last quarter, I would say a lot more than 50% of our customers or prospects have been either pure cloud or hybrid cloud environments. So it's something that needs to be addressed from a data lake perspective sooner than later.
Yeah, one question I'll have for you folks is basically that over half are basically are dealing with cloud in some way, shape, or form. Does it seem to be trending towards hybrid or towards where basically, this data lake is so complex we're going to put the whole thing in the cloud?
I think it depends. I think I've seen more hybrid than full cloud, but the ones that tend to be full cloud are the newer probably the younger companies that have less on-premise infrastructure to begin with, and they're starting everything from cloud, the cloud perspective.
Mm-hmm. Yeah, that makes sense.
Yeah. So as we look from the building of the data lake and the infrastructure components there, which seems to be stabilizing, the next step is the managed ingestion. How do we get data in? How do we capture rich metadata about the information so that we can have clear visibility? We can address the privacy and compliance issues that keep these from becoming more production level instances. And that's, I think, also getting better, and this is certainly an area where Zaloni spends a lot of focus. And as you've built this managed data lake, which has a rich metadata catalog, then you can start to deliver on the value of enabling high-quality information and reusable processes. I think in your previous slides you mentioned the whole concept of how do we operationalize this as workloads change, as you enable it to more folks, being able to operationalize the updating of data, the delta change within the ecosystem. These are all challenges that are different from the way they were in the traditional data warehousing space. So these are some of the challenges that folks are having. And as we look to the different types of solutions that are out there, you want to enable as much data to be ingested, organized, and cataloged as possible within the data lake. We want to be able to govern that information, cleansing, having spent a lot of my past lives in the data quality arena, I always think it's the deja vu all over again. We worry so much about next data architecture. How are we going to get data in? How are we going to access it? The concepts of governance and cleansing and quality of information kind of are always second tier, but they're bubbling up again here as well. And then lastly, how can we engage the business? We want to enable this access and engage more of the data analysts, data stewards, business users, the data scientists. They should all be able to collaborate. They should be able to discover the data that's in the lake without having to know how to query HCatalog or the Hive server. And then how can they enrich that information and provision it back out to other analytic applications, other operational applications, whatever it might be. And that's really where I think we still have a ways to go in the whole data lake journey.
Yeah, no question about that. I just want to seize on one of your points here, and it's going to seg to basically a point that you make in an upcoming slide where you lay out your own reference architecture, which is the whole notion of data quality, of cleansing. And the fact is that in a data warehouse, it was relatively at least conceptually was cut and dry, which is basically it was that the data the data was either dirty or it was cleansed to a specific, canonical form. Whereas in a data lake, it's going to be a much different creature. And the fact is that we did some research, actually, it's now coming up on about 4 or 5 years ago, where we looked at it basically as how is data cleansing, data quality, going to apply in the world of big data. And our conclusion was that it was going to have to evolve. And it's not that the old approaches were wrong, but it's really more of kind of a concentric circle in terms of that there's some data you're going to be using for exploratory analytics. And this is where you're basically trying to define the problem. You're not making any types of operational decisions at that point, auditable decisions. So they're just trying to get a sense of where should we be looking. And at that point, data quality is a much, it's still important, but you don't need to get it to basically that fine level of precision that you would need in a data warehouse where you're making real decisions that affect real business processes that may in some cases have real, let's say, regulatory compliance implications. And so and you hint at this basically in your slides that there are going to be different gradations of data. Actually, we had another way of putting it, which is kind of like a bullseye, where basically you're operating on different groupings of data on which you have different confidence levels in terms of its degree of quality, uniqueness, and so on. And you're making certain types of, let's say, judgments based on, the types of judgments you'll make on data that you have, let's say, 30% confidence level in. It's going to be very different from the decisions you make on data that you have, let's say, a 90% confidence level in. And so part of governance in the data lake is managing those, managing basically those data quality processes, and managing also basically, the retention, the storage of those different categories of data. And in turn, there may be different, rules, for engagement. For instance, different, rules for access depending on how clean that data is. So, and it's, as I said, it's something which you folks basically hint at, in one of your next slides. So I kind of just wanted to throw that little monkey wrench in there.
Thanks as always.
So, Tony, this next chart is one that also comes from your upcoming report, and I was wondering if you could describe this one a little bit for us, and also maybe double-click on two concepts in particular here, self-service and also collaboration.
Okay, got you. 10-4 there. This is basically, if you recall back to our reference architecture, this was in the data inventory, area. And I told you we were going to be, double-clicking down this. And what we found were basically two broad groups of functions and two broad groups of roles here. That there's a role for end users, but there's also a very necessary role for IT. It doesn't, in other words, when we start talking about self-service in this area, this doesn't mean that IT abdicates its function. Very much the opposite. They're kind of like, they're playing kind of an sort of an overseeing type role. More specifically, what we found this breaking down is basically into two streams. One was what we call data curation, which is more the end user, the business and the responsibility of business and analytics teams. And then on the technology side was the physical inventory. First looking at data curation, it's where you as the end user or you and your colleagues are building your own libraries of information, because you're not going to be, as I said before, you're not going to be able to rely on IT to do this. There's just not going to be the resource for that, given the fact that you're going to be looking at lots of different sets of information and trying to do different things. And so in this area, this includes a number of related tasks, includes basically profiling the data, doing data preparation, which basically would, in the old world, would have been called data cleansing. But it's a different type of creature when you're in a data lake, because basically you're taking different approaches. You're taking approaches that basically are probably more probabilistic, taking approaches that basically are that may have some machine learning. In fact, we believe that machine learning is really going to be essential here, because it's basically the system needs to give you an assist in making sense of how this data fits together. But as part of all this, what's really important here, what you cannot do without, is collaboration, because chances are no single group or no single person is going to have unique knowledge about all of the data, given the vast variety of data that's going to reside in a data lake. And so here you're going to need to have a way of sharing this insight. I don't, between, let's say, what in the old world would have been called power users, to say, we know something about the source of this data. I've used this in my, and it's useful for these types of problems, and these are the types of issues that you may have when you're basically trying to prepare this data. And so, or here's some of the, or here's basically a library of routines that we use that were successful in preparing this data. Here's a way to approach it. And so that collaborative data enrichment is going to be really essential. It'll also be essential basically in enriching the metadata. Out of the metadata comes a cataloging function. Out of that comes basically, and again, you may not be doing, Rome is not built in a day. Don't expect that when you curate data, you're going to be doing all these, but ultimately this is what it's all going to involve. Then, down the line, it's going to be, you'll be probably looking at matching data and trying to, identify where the duplications are. And from that, you may then start to derive, well, here, what is going to be a canonical record of, let's say, a customer in this new environment where we're ingesting all these new different data sources that go beyond name, address or account information. And in turn, at this step, every step along the way, the lineage has to be recorded in terms of what was done to the data, and and who did it. And so that's what, and so that's where, as I said before, collaboration is just going to be collaboration and machine learning are going to be huge here. We'll go into machine learning a little bit more in a moment, but then on the other side, which is the technology, which is for the IT folks, is that these are folks who are going to be, they're going to be in charge of the physical inventory, which is knowing and managing what data is in the data lake. That's not an end user function. This is ultimately basically the person, the people that are responsible for maintaining the Hadoop cluster. And this is where you're managed, and this is basically where they have to manage the data access. Now, I have to tell you that, and tag for security. Now, I have to say that this is an area where basically where business users or power users can contribute as part of the collaborative data enrichment, contribute their insight in terms of we believe this data is going to be sensitive. We believe that certain categories of users should or should not get access to this data. It's for business users to basically to make that clear during collaborative data enrichment during the curation phase. It's for IT to make sure it is enforced, or that there are rules there when there's the physical inventory, because they want to. It's ultimately IT is ultimately going to be accountable for basically who can access this data, not the end users, not the business teams. They also need to deal with data retention, and this is an area which basically has not been, with most organizations still early in their adoption stage, of Hadoop and of big data. We're not really thinking about life cycle, but but while basically, players like Facebook or Google, are not going, don't archive data, or at least are not really, are not archiving at this point. They might be doing, tiering. The fact is that you as an organization, your resources are not going to be infinite. And so they're going to have to make some decisions in terms of, what the, how long this data should stay resident, in the data lake. It's, you can't, storage may be cheap, but a lot of cheap storage gets expensive. And in turn, so that's part of basically managing the life cycle and workflow. And this is the area where you need to track data lineage. And the thing is, that's going to be a very interesting challenge, because basically you're going to have lots of tools that are going to be contributing their own lineage data. You're going to be getting it from the data lake management, folks like the Zalonis of the world. You'll probably also get some of that, from analytic tools that use the data, and so on and so forth. And you may get some of it also from the Hadoop platform. So this, this lineage is going to have to be rationalized. So you don't have 15 different, sources of the truth in terms of what's happened to this data. Scott, what's your take on this?
So I love this slide, and I think that the things that I would like to see you add, or we can chat about here, is the idea of automation. You mentioned machine learning. I think the automation between the curation and the physical inventory is really critical, because as we look to use machine learning techniques or other analytic techniques to make recommendations on how people should manage data as it comes in and the curation process and how that feeds back into a total data lifecycle management loop are questions and requests we're seeing from customers now. And the example I'll use is data retention and lifecycle management. We are starting to see that from some of our more advanced customers where, let's say, it's a retailer and they're trying to manage inventory, and the data only has relevancy for a certain period of time, and they're capturing petabytes of information over a week. And to store that, as you mentioned, there's commodity hardware and it's cheaper storage, but it's not free. and ultimately, it destroys the integrity of your data lake as you keep assets around that aren't really useful. So one of the things that we're working with customers to do is to build a data lifecycle management policy around where data lives in the data lake, how relevant it is, what kind of storage tier does it need to be engaged with, and then at what point does maybe that data get moved into an object store like S3 or blob storage on Azure, where they may want to keep it forever because at some point at the end of the year or 3 years from now they may have to pull it back, but they don't want to keep it in their active data lake. And managing the lineage and the lineage of that is really important, as you mentioned. So I think automation is sort of going to be the next phase, right? Right now we're still in the blocking and tackling of how do we build these data lakes, how do we manage and govern them properly. Automation is going to be the key for their next step into the future.
Yeah, I think we'll all be interested in looking at how folks like you, new players, that are tackling these problems, will be dealing with that life cycle, because that was never actually dealt with very well in the OLTP environment or the data warehousing environment. And now we need to deal with that in the data lake. So I'll be very interested to see the approaches that you folks come up with.
Great. So the last slide here that we're going to discuss is just a typical reference architecture. And as we look at Zaloni customers and when we discuss how they're going to build a data lake, how they're going to organize it, and ultimately how they're going to manage the information within it, we often use this as a talking point. And so, source systems from all different places, whether they be files, databases, ETL extracts. Streaming is a big thing we're seeing now. So for the Internet of Things and data streaming in from social media and other cloud-based sources, that's important as any other source within the organization. And we break things up into the concept of zones. So we'll have a loading zone, which may be inside your cluster in your data lake, or maybe it's outside of it, where the data gets landed for maybe some initial ingest preparation activities performed on it. But ultimately, it comes into a raw data zone that maybe has a very specific set of users that can have access to the information there. It's all of the data in its original unaltered format, and then we can tokenize information or privatize information as needed before it gets moved into, let's say, the refined or trusted data zone. And there's various levels and policies and definitions of what it means to be refined, trusted, or potentially turned into a discovery sandbox or an analytic zone. And these are all names that we use in this reference architecture. Our customers may have things broken out by the type of data, et cetera. But I think the key is defining the policies for what it means for data to be in this particular zone and who has access to that information within the zone. And then on the consumption side is who can connect to that information using something like self-service data preparation tools, whether that be a Zaloni tool or some other data preparation application. This is also where we can manage policies across zones on the relevancy of the information and the data lifecycle management. So that's, again, one of the things we're focusing on is how do we determine when data moves from one zone to another based on automated processing rather than it needing to be promoted by somebody manually. Again, I think automation of all of these processes, as much as we can get to them, is going to be really critical moving forward because the rate of change of data sources on the left is going to continue to grow and grow. So we just wanted to kind of bring this up as an opportunity to say these are the ways that you can think about your reference architecture, and that can help lead the governance policies for the rest of the data lake.
No, I think you've laid out some very interesting concepts here. And again, as I mentioned before, just focusing alone just on the different zones of data, your refined data, trusted data, the discovery sandbox, the raw data. And these are issues that we really did not deal with in data warehouses. We just assumed that all the data there was refined and it was for specific uses. data lake, not really the case. And so therefore, this is the type of thing where we're going to have to figure out how to manage diversity in the forms of data and how it's used. So very important, very important, basically white space for governance to really fill in there.
So, Tony, Scott, thank you very much for this. I wanted to give just a few moments to the audience to see if they wanted to jump in with any Q&A. If you do have any questions for either Scott or Tony, if you want to type those into the Q&A chat box, we'd be happy to address those. And while I give them 30 seconds to see if they have any questions, I did want to ask you guys one general question, which is, as we listen through all this, it seems like the phrase, the more things change, the more they stay the same, comes to mind for me. So I don't know, Tony, do you have a few thoughts on how data management has changed over your career? Because you've been right at this space for a little while.
Well, I do see that basically that metaphor just very much applies. And what I think back is basically when I was covering the emergence of data warehousing, and BI 20 years ago, basically. It's almost exactly 20 years ago. And I remember there was, at the time, basically, data warehouses and SQL databases were considered the big data of their day because this is the first time that data was, in a data store and it was independent of the application. And they thought, wow, we can now get a bigger view. And now that we had basically at that time client server, then we started to go, towards an internet, towards a web-based architecture. But with the rich clients, we could now do more than green screen reports. And so I remember going to a lot of those early TDWI sessions, and there's this one guy in the back of the room, and he was awfully obnoxious. And he was saying, "Do you realize, do you realize about what the quality of the data is that you're feeding in there?" And the fact is that was not really an issue that we really thought about before when we had individual systems where, they each had their idiosyncrasies and we had workarounds. But when you put those all together and you had now you had basically data that had, that had basically sort of, I guess sort of varying levels of sparsity or varying patterns of sparsity. And so, and that guy was, as I said, he was obnoxious. He was basically saying the emperor has no clothes on, but he was right. And so we're kind of in, hopefully in a less obnoxious way, we're kind of in a similar position today in terms of that when you look at how basically big data platforms or Hadoop was originally used, we put in log files. We never thought to clean them up. We never thought to basically restrict access on them because basically, how sensitive is that data and who's going to really use it outside of a few trusted data scientists? Well, guess what? Today, basically, we have a much greater variety of data, and guess what? Some of those log files are going to be sensitive. I'm actually participating in an IoT cybersecurity panel tomorrow night, here in New York, where I'm based, and we're just looking at, for instance, connected cars. And there already have been instances of. There was an instance, a very well-publicized instance of, I think, a Jeep was basically, it was a controlled experiment, which, and this was not even a self-driving car, it was a Jeep, and its software was hacked. And so the fact is that we have to take another look at this data that's coming that we didn't think was necessarily sensitive. It's going to be a lot more sensitive there. So basically, I think the issues of sensitivity, quality, are things that are going to be, it's kind of like deja vu all over again, except it's much more of a complicated problem this time around.
And I would just echo, I think it is the same problem all over again, but we have different tooling. The technologies have advanced to the point where we can handle them in a different way. If I look at what we, being someone who helped build out some of the, early stage data quality and data integration tooling, having the in-memory capabilities, the ability to ingest data at different rates, the different in-memory processing architectures. Now we can hopefully learn from how it was done before and do it in ways that improve not only on the speed of what we can do it, but also the results.
All right, thanks, guys. Hey, I've got one question here that I wanted to pass, and I'm going to hand this over to Scott, actually, because it's very specific to our Zaloni data lake reference architecture. And that question, Scott, is what is the transient loading zone that we have in the architecture?
Sure. So this represents a place that may be outside of the data lake where data that's being ingested initially may land in a very transient way to have some different types of processes run against it. So maybe you need to remove some sensitive data, or maybe data needs to be transformed in some way before it can come into the actual data lake in what we would call the raw data zone, which is usually data in its native format. So it's not always used, but in some cases we found people want processing to occur outside of the lake before the data can get in, and we call that in the architecture the transient loading zone. So it's more just the name that we use in the architecture, but it's a way to handle sensitive data outside of the data lake.
Perfect. All right, thank you very much. Well, I don't have any other questions, so what I'd like to do is go ahead and close this up. Thanks so much, Tony, and I know we're looking forward to seeing your report published and further work throughout the year on this topic. It's very interesting to us. Okay, and to the rest of you, thanks so much for participating today. We're going to follow up with you via email with a link to the recording of this webcast, and we're also going to send you a link to the charts. And please feel free to reach out to us if you have any other questions or you want to continue this conversation, and if there's anything we can do to help you modernize your data lake architecture. Have a great rest of the day. Bye-bye.